Welcome to Pre-Calculus with Miss Niskanen, and today we're going to take notes on end behaviors. We're going to do it in a foldable. For today's foldable, you're going to need several items: your school-issued straight edge, a pen and a pencil, and 3 colors. They don't have to be highlighters. Mine just happen to be highlighters. They could be color pencils or any fancy color pens. And you will need your 4-door foldable. Okay. On the end behaviors, what we're going to talk about is how we can picture how this foldable will help us. And we're going to talk about end behaviors for a function, and functions and end behaviors mean graphs. So the first thing we're going to do is we are going to highlight our x and y axis. So yeah, I made this tear is not so nice. That happens sometimes when you're making these. Okay. I have my x-axis, which I'm highlighting blue. So I'm going to make my x-axis blue. And I'm going to make it blue on the inside as well. So it's nice and wet right now. Okay. So this is my x-axis. And I'm going to label it x-axis on the inside. I'm also going to label my y-axis with my range color, which is red. So I'm going to highlight my y-axis, and I'm using pink. And the blue and pink make a really nice lavender color right in the middle for the origin. And I'm going to do that on the inside and the outside. I'm going to label y-axis. Okay, so I have my x and y axis labeled. And I'm going to color it on the outside as well. Okay. Well, almost. It's a little tricksy on the sides, on the edges where they meet. Especially if I didn't fold it quite nice, which is what looks like it's happening here. Okay. And we are going to label it end behaviors. So I'm going to put end behavior for the foldable. And I'm going to label it on the inside as well. So I'm going to end up writing over this will behave. So I have it labeled on the inside and the outside. And on the back, I'm going to put my name. And I'm going to put period and, put whichever period you're in. So I'm going to call it pre-cal. All right. Since we're dealing with an x and y axis, that means that we have quadrants. So we have quadrant 1, where my x values are positive and my y values, my y values are positive. But it's really my f of x values, and we'll see what that means. So the graphs are going up. Excuse me, and I am abbreviating the word quadrant to Q, because quadrants are something we've done since Algebra 1, maybe even since 6th grade. Quadrant 2, this is where my x values are becoming negative. But my f of x values are still going up. I have quadrant 3. It is counterclockwise, so it starts here and goes around the clock backwards. Again, my x values are becoming negative. But so are my y values. My f of x values are becoming negative as well. And since I'm here, I'm going to do that already for this y, because those are also going to be negative in quadrant 4. But what makes it special is the fact that the x values are positive. Okay. So I have an obsession with coloring in my arrows to make sure that they look nice. Although sometimes it just makes them look worse. Okay. So this is the beginning of my end behaviors. From this, I'm going to be able to write some definitions about how the end behaviors are looking. This foldable is only going to help me with the two main end behaviors. There's actually a third end behavior, but it doesn't quite fit into this foldable. So what I get is, I'm going to open this up on the inside, and I'm going to draw my f of x, and that's where the third color comes in. So this is my f of x, and it can do some really weird stuff. It doesn't have to be all pretty like this, doing this kind of weird thing. So this is just really to get me along the lines of what my graph is doing. And again, the f of x is truly just the graph. The f of x is truly just the graph. As we work on the end behaviors, what happens is, so your graph should look like that. If you have to pause, because I'm going to close it and talk. What happens is, as I look at my graph, I start to look at where the ends, where the far left end, it's either going up or down, or it could be coming out to a horizontal line, but that's a whole nother story and it's not going to fit into this foldable. Or I look at my right side end behavior. As x gets really, really, really big, my graph is either going up or down, or again, it could be going out horizontal, but again, it doesn't fit into this foldable. I don't have a way to make that fit really nice. I'm thinking about it, but I don't have a way to make that fit really nice. So what I do is I go, this is the way my graph looks. Now, my graph is not going to look like this in the middle. What I'm looking at is where the arrow's pointing. So I don't care what's going on in the middle here, but what I care about is where is this arrow and where is this arrow going. And if it's a function, we're never going to be able to open, like these two doors will never open because that's not a function. These two doors will never open at the same time because that's not a function. The green lines are not passing the vertical line test. So we look at the cases. As x goes to positive infinity, so x goes to positive infinity, and we would write this as, let me zoom in just a little more, as x goes to positive infinity, tell you, I'm obsessive compulsive with this. There's a comma hiding after the infinity. F of x goes to positive infinity. So my graph goes up. That's one way to write it. That's the way we spend a lot of our time writing it. But there's a calculus way to write it, which is the limit. And it looks like this. The LIM as, or the limit of x as x goes to infinity, so it would go like this. And then it would say f of x goes to positive infinity. And that's because as we're passing to the right on our graph, this graph is actually traveling up. So that's how we would write that one. Well, if it weren't in quadrant 1, but it were in quadrant 2, or sorry, not 2, quadrant 4, well, you can see my x going to positive infinity, so we're going to have that statement as x goes to positive infinity. F of x goes to, well, now I can see my graph is going down. It's going to negative infinity. So we would say as comma. And if we put it into limit notations, we say the limit as x goes to positive infinity, f of x goes to negative infinity. I wish it fit in one line, but it didn't. Okay, so I'm going to pause here, and I'm going to write the others, but you can see where we're going, because when I open up the third quadrant, if the graph were going down on the left side, as x goes to negative infinity, and we're going to flip that around so it makes sense, f of x goes to negative infinity. So I'm going to pause and bring you back in when I'm done there. Okay, so you can see that as x goes to negative infinity, the graph is going down to negative infinity. So as x goes to negative infinity, f of x is going to negative infinity. And this is a horrible comma. It looks terrible right now. It's a little bit larger than it should be. But the limit as x approaches negative infinity, f of x approaches negative infinity. And I would have the same thing on the top. So on the top, as x approaches that negative infinity, as x approaches negative infinity, f of x goes to positive infinity because the graph is going up. So the f of x is going to positive infinity. I wish I wrote that sideways a little bit more. It's pencil, I might fix it right now. And the limit as x goes to negative infinity, f of x is going to, it's just driving me nuts that that arrow's not quite right. Okay. It goes to positive infinity. So as x becomes more and more negative, we have the limit going up. These are two ways to say the same thing. And the catch is, this is x approaches negative infinity. So that arrow means as x approaches. So it's kind of like a shortcut kind of thing going on there. All right, so what you do is, then you look at your graph, so we zoom out just a little bit, and we say, oh, my graph is going down on the left side, and it's going down on the right side. And again, I don't care what's going on in the middle. The graph can look all kinds of ways. Yeah, look at my nasty fingers with the markers. And this is the statement for the end behaviors. As x goes to negative infinity, f of x is going to negative infinity. As x goes to positive infinity, f of x is going to negative infinity. And I could say it in the limit notation as well. Or maybe my graph was going up. And if my graph is going up, this would become the statements that I would say. Or maybe my graph was both going up. And then these would be the statements that I would say. Or one was going, it started high and goes low is how I would say it. I don't know how I'm going to hold this one. Power of erasers. And again, it doesn't matter. It doesn't matter what's going on in the middle. What matters is where are those arrows going and where are they pointing. And that is how we do end behaviors.